Good day, students. We're done discussing the relationship between different properties of gases, such as the volume-pressure relationship on Boyle's law, the volume-temperature relationship on Charles' law, and last, the pressure-temperature relationship of gases discussed on Gay-Lussac's law. So now, for today's lesson, I want you to observe and watch this video and answer this question. What properties of gas is shown in this video? Take note to observe what happens on the balloon on this video.
David's gonna be blowing up a balloon with that much water in it. Let's go. Crap. Okay. Yeah, this is just a few minutes after the dirt bike stuff. Getting a little lightheaded. Show them how big it is. It's that big. It's like huge. Let's go back.
So as you can see, the balloon pops up. Now, what properties of gas are shown on this video? The answer is volume and its amount of gas. So what is the relationship between volume and the amount of gas? And the answer that one theory is proposed by Lorenzo Romano Amadeo Carlo Avogadro, an Italian scientist most noted for his contribution to molecular theory, now known as Avogadro's Law, which states that equal volume of gases under the same condition of temperature and pressure will contain equal number of molecules. The relationship of volume and amount of gas is discussed in Avogadro's Law. So for today, we will talk about the concept of Avogadro's Law, and we will use some mathematical equations to show their relationship. So as the gas inside an inflated balloon occupies a volume, as the air is added inside the balloon, the gas required more space for them to occupy. As a result, they increase the volume inside the balloon and make it to expand. So, as we can infer, as the amount of gas increases, the volume or space occupied by gas molecules also increases. Avogadro's law states that at constant pressure and temperature, the amount of gas is directly proportional to the volume. When we say directly proportional, as the amount of gas increases, its volume also increases. Or, as the amount of gas decreases, its volume also decreases. Now, let's plot some details about volume and amount of gas relationship on a graph. So let's say we have a cylinder containing an amount of gas. We're having 0.50 mole, occupies a volume of 2.50 ml. Now, as we add more air molecules for having 1.0 mole, they occupies 5.0 ml. Then we add another amount of gas inside the cylinder for them to have 1.5 or 1.50 mole and occupies 7.50 ml. Now let's plot it on a graph. So as you can see, as we add more air inside the cylinder, the amount of gas increases. So from 0.50 mole, we added more air to have 1.50 mole. So the amount of gas increases. While the amount of gas increases, the volume inside the cylinder also increases from 2.50 ml. It changes into 7.50 ml. So for the Avogadro's law, it states that at constant pressure and temperature, the amount of gas is directly proportional to the volume. On this example, as the amount of gas increases, the volume of a gas also increases. Now, here is an example of a situation wherein it shows the relationship between volume and amount of gas. First one is a flat tire takes up less space than inflated tire because it contains less air. Second one is that lungs expand as they fill with air. Exhaling decreases the volume of the gas. As a result, it also decreases the amount of gas inside the lungs as we exhale. Now, let's use some mathematical equations to show the relationship of volume and amount of gas on Avogadro's law. Volume and amount of gas relationship states that at constant pressure and temperature, the amount of gas is directly proportional to the volume. So volume is directly proportional to the amount of gas, and this relationship is constant. Having this equation, volume is directly proportional to the amount of gas, and their relationship is constant. Now, for us to identify the equation to be used, if one property, either volume or amount of gas, is unknown, we need to divide both sides of the equal to the symbol constant because we need to put the constant sign or constant symbol on one end of the equal. So to do that, we need to divide both sides of the equal to the quantity beside it, which is the amount of gas. To cancel out the amount of gas and leave the constant sign into one end of the equal, having this equation. So it is constant that the volume is directly proportional to the amount of gas. Now, if we have a constant relationship between volume and amount of gas, if there change happen, this relationship will still remain. Now, what if one quantity between the initial volume and amount of gas and final volume and amount of gas is unknown on a certain situation? Now, to determine that unknown quantity, we need to have an equation, and to do that, we need to cross multiply this equation for us to have this one, wherein volume or the product of volume and initial volume and final amount of gas is equals to the final volume and initial amount of gas. So this equation is to be used for us to determine the quantity of one of them if it is unknown on a certain situation. Now let's try it on our problem. So let's say we have a balloon containing 2 moles of helium and occupies a volume of 0.8 liter. What would be or what the volume be if 3.5 mole of helium is added to the balloon? And to do that, we need to use the GRISA given required equation solution and answer. First, let's identify the given. So, the initial condition on this word problem, we have the 2.0 mole for us to have the initial amount of gas. We also have the 0.8 liter for us to have our initial volume. Then on this problem it says that 3.5 mole of helium is added to the balloon. So this 3.5 is our final amount of gas. So the one that is not given or being asked on this word problem is the final volume. So what would be the final volume or the change happen on the volume on this word problem? Now, to determine the equation to be used on this word problem, having the final volume as the required or the unknown quantity, we need to divide both sides of the equal to the quantity beside it so that the final volume will be left on one end of the equal. So we need to divide both sides of the equal with initial amount of gas so that initial amount of gas beside the final volume will be cancelled out for us to have this equation. So final volume is equals to the product of initial volume and final amount of gas over the initial amount of gas. Now let's have it on, or let's solve this equation. So final volume is equals to the product of initial volume, which is 0.8 liter, and final amount of gas, which is 3.5 mole, over the initial amount of gas, which is 2 moles. So first we need to get the product of initial volume and final amount of gas. So 0.8 multiplied by 3.5, we will have 2.8 liter moles. Now all you have to do is to divide the 2.8 liter moles to 2 moles for us to have our final volume. So 2.8 divided by 2, we will have 1.4 liter as our final volume. Now let's identify what happens to the amount of gas and volume on this word problem. So as you can see, from 2.0 moles, it changes into 3.5 moles, causing the amount of gas to increase, while the volume from 0.8 to 1.4 liter, it causes the volume to increase also. Now let's have another one. So let's say we have a 10 gram of nitrogen has a volume of 2 liter. If the amount of nitrogen is increased to 45 gram, what new volume will result if the pressure and temperature remain constant? So let's identify the givens. So on initial condition, on the first condition, we have 10 grams as our initial amount of gas. We also have 2 liter as our initial volume. Now, on this given problem, they add 45 gram of nitrogen gas. So this 45 gram is our final amount of gas. Now, the question is, what would be the new volume? So what would be our final volume if the pressure and temperature remain constant? So the unknown one is the final volume. Now, to determine the equation to be used on this problem, again, we need to divide both sides of the equal with the quantity beside the unknown one. So on this problem, we have the final volume as the unknown quantity, and the quantity beside it is the initial amount of gas. So we need to divide both sides with initial amount of gas so that initial amount of gas is being cancelled on one end of the equal. and we will give this equation. Final volume is equals to the product of initial volume and final amount of gas over the initial amount of gas. Now let's use it on a solution. So we have the final volume equals to the product of initial volume, which is 2 liter, and final amount of gas, which is 45 gram, over the initial amount of gas, which is 10 grams. So first we need to have or to get the product of 2 liter and 45 gram. So 2 multiplied by 45, we will have 90 liter gram. Now all you have to do is to divide 90 liter gram into 10 grams for us to get our final volume. So our final volume is equals to 9 grams because 90 divided by 10, we will have 9. Now, we get the unit later because we need to cancel out the grams, and the unknown is a volume. So now we have the initial condition and final condition for this word problem. So we have an initial condition for the amount of gas, which is 10 grams to 45 grams as the final condition. That makes the amount of gas to increase. Well, for the volume from 2 liter to 9 liter, it makes the volume also increase. So for Avogadro's law, it states that at constant pressure and temperature, volume is directly proportional to the amount of gas. As the volume increases, the amount of gas also increases. As the volume decreases, the amount of gas also decreases. So that's it for our discussion for today. Hope you understand our discussion. You can now proceed to your task activity. Thank you.